Imagine that a robot can build an entire 200 square meter home in a single day. Now imagine the same technology being adapted to construct radically healthier environments and even future habitats on the moon. Our guest today is Professor Dr Jan Golembiewski, architect, researcher and entrepreneur, and the co-founder and CEO of Earthbuilt technology.
Right now, we're facing a massive crisis, and it's a crisis of housing affordability and environmental damage. Earthbuilt is essentially a print head. Instead of printing a line of text, prints a line of law. And so we went and invented Charlotte, a six-legged robot, and an arachnoid kind of robot, which allows us to print whilst maintaining stability on the ground, and the movement of the printer is using legs rather than wheels. 20% of our emissions still come from our construction industry. I reverse engineered the whole process of construction down to the most basic and abundant material that we have on Earth, which is Earth itself. We just print what's needed, so there is no waste. There's plenty of Earth on the moon. The Earth on the moon is called regolith. You can't get an astronaut to wear gumboots and go out and start building when they leave their craft. The UN says that we need around 100 million homes, and we can provide them. If we are in homes that are environmental, and we can see that they're environmental, and we know that they're environmental, we're going to feel good about ourselves. The environment that we build around ourselves contains stories.
Yeah.
There's no such thing as neutral in design.
Welcome to Spacefront Conversation, where we explore the frontiers of technology, space, and human ingenuity. I'm your host Divya, and today's episode we are diving into a fascinating intersection: robotics, architecture, mental health, and the future of construction, both on Earth and beyond. Imagine that a robot can build an entire 200 square meter home in a single day. Now imagine the same technology being adapted to construct radically healthier environments and even future habitats on the moon. Our guest today is Professor Dr Jan Golembiewski, architect, researcher, and entrepreneur. He is the director of Psychological Design, a practice specializing in design, psychology, and the neuroscience of how spaces affect our minds and behavior, and the co-founder and CEO of Earthbuilt technology, which is reimagining how we build using just three inputs: earth, fiber, and energy. From cutting-edge evidence-based design to sustainable construction systems, Jan is helping shape the next generation of buildings. Places that are healthier for our bodies, our minds, and our planet. Let's jump in. Jan, welcome to Spacefront Conversation. It's an honor to have you here.
Yeah, thanks, Divya. I'm really happy to be here.
And I should say properly, you are wearing lots of hats: architect, researcher, director of psychological design, and CEO of Earthbuilt. Before we unpack all of that, how do you usually introduce yourself?
Well, by the time I'm introduced, usually it's the end of the podcast with all those hats. It depends on who I'm speaking to. At the moment, I'm really trying to promote Earthbuilt. It's a technology that I invented several years ago, and we're trying to bring it to market. My co-founder and I are trying to bring it to market because it's really important for humanity. We'll go into why in a minute, but it has taken a lot of my attention, all of my attention perhaps, because it's so important. Not to say that my other hats, such as psychological design, are not important. The psychological aspects of design are critical because we live in a designed world. Everything we do is in interaction with the designed world, and it does affect how we behave. It does affect who we are. And so it is of absolute importance. But right now, we're facing a massive crisis, and it's a crisis of housing affordability, and it's a crisis of environmental damage. And unless we address the screaming wheels, we can't get into the fine print.
Yeah, right. So before we dive into your personal journey, I would like to start on Earthbuilt technology and robots that you built. You are the co-founder and CEO of Earthbuilt technology. For someone hearing about it for the first time, what is Earthbuilt and what are the problems are you trying to solve?
Earthbuilt is essentially a print head. Imagine the printer head in your home printer. It's that little cartridge thing that goes in the machine and goes zzz, 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 across. Our print head, instead of printing a line of text, prints a line of wall. So it will print out a house in a very short time. And the printhead it can go in any technology. Any vehicle that can carry it will work. Minimally, we want it on an excavator or a crane. We might use one of those A-frame gantries, which are typical for 3D printing technologies for construction. But each of those typical technologies has its own problems. And so we went and invented Charlotte, which is a robot, a 6-legged robot, and an arachnoid kind of robot, which allows us to print whilst maintaining stability on the ground. And the movement of the printer is using legs rather than wheels.
That's amazing. You have described Earthbuilt as using 3 main inputs like earth, fiber, and energy instead of dozens of materials we see in conventional construction. How does that work in practice?
Excellent question, Divya. The problem that we're trying to solve is the problem of ultra-processed construction material. Materials started being processed and over-processed with the firing of bricks some 7,000 years ago in China. It was really convenient at the time because you could take a unit of a house, of a building, and you could bring it to market, literally to the market, and it could be sold and then deployed later. Yeah. So it became a very tradable commodity, which made it very useful for construction. And the fact that it had to be fired with an enormous amount of carbon was neither here nor there 7,000 years ago. No one realized that they were damaging the environment, and quite possibly back then they weren't. But now, 7,000 years on, we are at a time when we have to start moving away from these ancient technologies. We've been using them for so long that they really have choked up our environment. With every breath that we breathe, we're breathing in emissions from our construction industry. 20% of our emissions still come from our construction industry, and it was also the first industry to start heavily polluting. So we could say that a great deal more than just 20% of the pollution that we breathe comes from that industry. So we had to start thinking differently about our construction materials, our ultra-processed construction materials. And I started thinking about it and realized that actually with any process, we add carbon and cost because people have to get involved and transport and machines.
Yeah.
And the less we do to our raw materials to make them appropriate for our modern methods of construction, the cheaper they're going to be and the less carbon. So I reverse engineered the whole process of construction down to the most basic and abundant material that we have on Earth, which is Earth itself.
Yes.
It's a fantastic building material, if only you can build with it. But it tends to crumble. It's like building sandcastles. And there are methods that people have developed to use Earth as a building material. For example, people have started putting it in sacks and then laying one sack over another and compressing those sacks. And that's a fabulous method. But if you've ever tried to do it, it's really hard work. Sacks of sand are unwieldy. They don't want to be moved into the right position, and they are heavy.
Yeah.
So I'm a really strong guy, but I can only work in that kind of construction environment for 3 hours a day. So you need teams of people of my size to be able to do it, and for a long time because it's slow work. So that method isn't appropriate for a modern building technique. Other methods include rammed earth. Everyone loves rammed earth. It's beautiful material. The problem is that rammed earth, at least in Australia, is 20% cement, which means that rammed earth in Australia has more cement in it than concrete. So where's the benefit there? It's aesthetic, but it isn't environmental. Other methods of building with earth include adobe blocks, which are sun-dried blocks of clay. And they're fabulous materials, but once again, there's a lot of labor. You have to make a block, then you have to dry the block, then you have to lay the block.
Yeah.
What we're doing is we're deleting all of that, saying we take the earth, or we can take recycled other materials. We take the earth, we put it in our machine, it is pumped using relatively clean electricity into a compressor, it is compressed, and it is bound in fiber. That might be hemp or jute or copra, whatever is available. Very cheap material, and that becomes the binding material. Technically, the binding is only on the outside edge.
Okay.
The compression of the earth on the inside maintains the compressive strength that's required of a structural material. And the binding around the outside edge is what holds it together instead of glue or firing or cement.
Amazing. So we opened the episode with almost sci-fi image, a robot building a 200 square meter home in a single day. Can you walk us through how close we are to the reality and what the machine actually does, step by step?
It was a massive vision and very audacious, but we have to be audacious right now.
Yeah.
We've got no choice. We're facing a crisis and we have no choice. And whatever that crisis is, whether it's a housing crisis or whether it's an environmental crisis or whether it's a cost of living crisis, whatever it is, we're facing those crises, and those crises can be solved by an efficient building method that doesn't cost the world. Now, the robot is a vehicle, and it's a very dynamic one. It allows us to build using complex architectural ideas really efficiently. There's no waste because the robot knows when to start and when to stop and where to lay its material. In the same way that when you're printing with a printer, you don't spread ink all over the page and then come back and clean it up. That is, in fact, how construction is done currently. We just print what's needed. So there is no waste. The robot legs allow at least 3 or 4 points of stability at any given time. So the machine is really stable whilst it's printing and moving at the same time. That's why it's got so many legs. Other reasons for having so many legs is a building site is very rarely flat. There's stuff everywhere, and it allows the robot to step over walls, to step over contraptions and building materials, whatever there is around, and get around all of that to build what's needed where. So it's just a different way of thinking about the vehicle. We went and prototyped it over the last year. It was a very expensive prototype, but it's only a third scale. We have yet to build a full-scale one, and we have yet to finance that. So we are looking right now at whatever possibilities there are to finance that. But right now, we don't have to jump straight into that robotic technology. We can use an A-frame technique or a crane or whatever it is. There are other vehicles for the Earthbuilt printhead for the time being. But we are heading down that path, and we will be printing with the robot before too long.
That's a unique approach. Yeah. So from a tech.
There is one other reason why we went for the robot, and that is that the robot allows the building technology to be totally autonomous.
Yeah.
In all likelihood on Earth, it will never be, because the owner of the robot is going to want to be there. And besides which, no one wants great big spiders crawling around without supervision. But it allows us to build on the moon.
Yeah.
There's plenty of Earth on the moon. The Earth on the moon is called regolith.
Yeah.
It's much drier. It's very sharp and it's very hard. But it is actually an excellent building material and very well suited to our compression technologies. And so we're able to use the same technology to build on the moon. And that is a real convenience, because on the moon, we don't have anything. We only have that dust and some sun. We don't have a Bunnings there. We don't have hardware shops. We don't have people. You can't get an astronaut to wear gumboots and go out and start building. When they leave their craft, that's a mission. You know, if they go out of their craft for 20 minutes, that's a mission. And it's not enough to build a house or a dwelling. Yet when landers arrive on the moon, they're going to have infrastructure for all the technology that they're bringing with them. If you're spending $500,000 sending some little satellite thing or whatever it is, sensor to the moon, are you going to want it to be unloaded and dropped into the dust, to be hit by micrometeorites and exposed to the incredible radiation and temperatures there? No. You need a house for it. You need infrastructure for it. And so the international space agencies are starting to realize that the infrastructure on the moon is the first step to anything else going to the moon, whether it's manned missions or unmanned missions. And the same with Mars. And it just happens that our technology is small enough to be collapsible, it's lightweight, and it can go to the moon. It can step out of the landers without any assistance and start building infrastructure for all the other equipment that follows. It won't even take a whole payload.
Yeah. I'm just trying to imagine the entire process.
It's about as efficient as it's possible to get. There are other builders out there who are really interested in building infrastructure on the moon. There's one American one that's been given something like $100 million to develop a technology. They invented something that looks a bit like our Charlotte. It is a sort of legged robot thing. But it requires a nuclear reactor to be on the moon. They require us to get there first, so they've got the infrastructure to get their machine, which isn't, frankly, as good.
So moving on, from a technical and logistical standpoint, what have been the hardest parts? Materials, robotics, software, site preparation, regulations?
Money. Getting money for our project feels like trying to fill a balloon with the wind. There's plenty of wind, but have you ever tried to use wind to fill the balloon? So we need people to come forward and lend us their lungs. We need people to yell from the rooftops that this technology is needed, because it is.
I agree. Yeah. So the world is also facing a housing and affordability crisis. How do you see Earthbuilt's approach helping both in places like Australia and potentially in low-resource settings globally?
We see it as the solution. The UN says that we need around 100 million homes, and we can provide them. It's our mission to provide those homes, and cost be damned. We need to pay for our equipment. We need to pay for some minimal things, but our mission is not here to make money for ourselves. Inevitably we will, but our mission is to build homes. We want a home to house the homeless. And in Australia, it does look like our first missions are going to be building for homeless people, whether it's in Queensland or New South Wales. Projects in both places seem to be heading toward coming together. You know, homelessness is a real problem, and we can solve that problem provided we can get land. So The next stop will probably be America. There's a lot of interest for similar reasons in America, or in India. There's also a lot of interest in India.
Yeah. So from a sustainability perspective, how does an Earth-built home compare to your typical home in terms of embodied carbon, waste, and long-term performance?
The parts of the home that are Earth-built, I can speak to those. There are parts of the home that obviously are not made out of Earth-built because they're not made out of Earth. You can't make plumbing out of Earth, for example, nor electrics.
Mm-hmm.
And so there are lots of parts of the home that we have no say in because that's not what we're involved in. But the structural part, the walls, are the bit where most of the carbon in a home comes from. And typically in a home, depending on the construction style, it will be between 10 and 55 tons of carbon in that home as an embodiment. Our technology can build that home in less carbon footprint, I should say, than a steak dinner for two. In other words, as we in Australia say, bugger all.
Yeah, it's really good to imagine, on making sustainable homes.
It's about making homes without ultra-processed construction materials. The carbon, the cost, the time, the insecurity, the supply lines,
Labor.
the labor, everything. It all boils down to those ultra processes.
Yes.
One process after another. There's quarrying, there's transport, there's chemical releasing agents and bathing, and there's everything goes into these materials. By the time the materials can't, goodness knows what they are. We look around us here, there's hardly any materials that we can even recognize. Even what we see as wood isn't really wood. This material around us is a kind of plywood, which contains materials from at least 3 continents, including lots of copper arsenate, which comes from both the USA and from Zambia and Africa. There's a lot of shipping in that. There's a lot of insecurity.
Yes.
If a material can't come, then what? We have real problems with our ultra-processed construction materials, and they create a lack of resilience. And the problems are exacerbated in places that are hard to get to, such as the outback, whereas our technology thrives in such places.
Yeah. So when you think about lunar or Martian construction, what part of Earth-built's construction transfer naturally, and what would you need to radically change?
So this is really a question for our engineers. We work very, very closely with an engineering firm called Quest Robotics, and they are entirely responsible for everything that happens extraterrestrially. We have an agreement with them that the extraterrestrial thing is their responsibility and we help them, and the terrestrial thing is our responsibility and they help us. Okay. So they're experienced space and robotics engineers. Mm-hmm. In their team, they've got people that have worked for NASA, at least 2 people that have worked for NASA. Mm-hmm. They've got people that have made successful satellite launches. They're people who really know what they're doing. And they do have a bit of a process to go, a bit of an engineering process. They've got to do all sorts of things. But if I were to paraphrase what I believe that they're going to have to go through, I'd be doing a lot of guessing.
Yeah.
Machines going to have to be tested with regolith simulant instead of with earth. We're going to have to use a different membrane. We probably won't be using an inline knitting machine. We'll probably be using a wrapping machine. We'll probably be using some sort of ultra-processed wrapping agent rather than a natural fiber. So ultimately, we'll end up with something looking a lot different. If we use a urethane, it'll probably have a foil in it to reflect radiation and to protect the material from the extreme temperatures and create insulation. What we might end up with are some sort of metallic-looking domes. Whereas on Earth, things will look much more organic, much more like linen suits.
Yeah. So you mean to say they look more likely kind of igloos?
If you're doing an igloo-like structure, vaults and domes, then you don't need roofs. So they're much cheaper. You don't need any other materials. And our technology is entirely capable of that, especially with the Charlotte robot. If we are putting roofs on, standard roofs, we're going to need standard materials for those roofs, which adds carbon, it adds cost.
I agree, yeah.
But it doesn't add it to what you would have to pay anyway, because we have to pay for a roof.
Yes.
If you're building a house, unless we do use vaults and domes. Yeah. And so we are talking with some of our potential buyers about modeling homes that are made of vaults and domes. They will look much more like the kinds of homes that you see in Tatooine in the beginning of the Star Wars series. So they're going to look kind of earthy and unusual and sort of a bit primitive, but they'll be cheaper and they'll be environmentally very, very sound. So there might be some people that prefer it.
Yeah, I think most of people are becoming, sustainable conscious. I think they would definitely prefer.
There are some people and there are some markets that are more ready for it than others. I go to India a lot, and in the south of India, there's a real appetite for that kind of construction. Whereas in Australia, I think that your average Australian person is going to want something that looks like an average Australian house, at least for the time being. But then there will always be some people on the edges who go, no, I don't want the average Australian house. I want that. I want the one from Tatooine. And then there'll be other people who want architecturally designed homes. And the robot gives us the ability to be able to make really interesting shapes without added cost. The added cost that you'd normally have in mapping these shapes and getting the builder to get them is significant. But if the robot is programmed to do it, it won't cost anything else. And we can cobble walls out and in. We can make some great shapes.
You really have got fascinating combination, deep psychological research on how spaces affect us, and a construction system that could radically change how fast and how sustainably we build them. I would love to connect these two worlds more explicitly. If robots and automated systems build most of our future habitats, how do we make sure those spaces are deeply human?
That's a very good question. And obviously it's something that's very, very close to my heart as well. I want to thread the needle on my two big passions. At the moment, I'm trying to keep them somewhat separately, not to muddy the messages. But in truth, they come together quite well. The sorts of spaces that we find psychologically very appealing are spaces that carry stories that are positive for us as humans and as individuals. And if we are in homes that are environmental and we can see that they're environmental and we know that they're environmental, we're going to feel good about ourselves.
Yes.
And it's valid. We should be feeling good about ourselves because we actually are doing good for the planet. Yeah. So, we are creating good and we will feel that. It will be present.
Yeah. So when robots are doing the actual construction, what does that free you up to do as a designer and a researcher? Do you see it enabling better psychological design because you are less constrained by labor and traditional methods?
Actually, probably the biggest benefit for the psychological aspects of design will be that it will free up budgets.
Yeah.
It will make the hard work of construction that much cheaper. So that if we do have money, we can actually spend it on what we want to spend it on. Making the spaces just right for us, making them touch us as persons, making us do the things that we need them to do, to have more opportunities to act outside of the house and inside the house in unusual ways. It really does open a whole gamut of possibility the moment you're reducing budgets. At the moment, the way we build is so tight, so budget constrained, that if we want to do something extra, it's really hard. Because if we're adding one extra room, adding an extra space, maybe you need an office to do your podcasts in, right? And earth is very good material for that because it absorbs sound very nicely.
Yes.
You could do it if you could afford it.
Yeah.
But if you're competing for that same money to put in a kitchen, you're going to put the kitchen in first.
Yeah.
And our budgets regarding homes are just so tight. And so it's going to liberate those budgets to give us the spaces that we need.
Yeah. So if you imagine a neighborhood or even a lunar base fully built with systems like Earthbuilt, what are the psychological and social qualities you would most want that environment to be or to have?
It's a big question. It really depends on who's going to be there. And I can't put Earth and lunar structures in the same category there, because if we're building for people on the moon, we're going to have to build whole worlds. Yeah. Because the moment people go outdoors, they're going out into the most inhospitable desert ever. There's no atmosphere.
Yeah.
It's hot during the day and it's cold at night.
Yes.
It is, the radiation is terrible. So we're going to have to build dome-like structures that really filter the sunlight as it goes in, captures some heat but doesn't release it all at night. And we're talking about creating very basic environments that allow our environmental niche to thrive. We live on Earth in a Goldilocks zone. The moon is no longer in that Goldilocks zone. So we'll be using our technologies to create those Goldilocks zones. On Earth, we're actually in a Goldilocks zone already. So we're able to build things according to what we need. And it sounds glib, I guess. The most important psychological aspects of design is that we're building what we want and need for ourselves. We're building for our social and for our aspirational and for our and for meaningfulness. We're building for us as complete humans on Earth, and a lot of that is actually turning the house inside out to create opportunities to interact with the natural environment, for example. Whereas on the moon, it's exactly the opposite. We'll be turning it inwards to create an artificial environment that has aspects that we can recognize as natural on Earth, but they're definitely not natural on the Mars or the moon.
So, Dr. Jan, I think there's often anxiety around automation and replacing jobs or dehumanizing processes. How do you think about dignity and human agency in a world where robots are building homes and hospitals?
It's such a good question. And I believe that it's going to create more opportunities for work, not less. Mm-hmm. The things that we're really suffering from in this sector here in Australia and in the world generally is a productivity crisis. That the people that are working in these industries just aren't producing enough. They're not producing fast enough. It's too costly. It's too slow.
Yeah.
Our technology is going to make it much faster. It's going to get rid of the biggest bottleneck in the whole construction industry. That is going to enable our labor to be much more effective, not less. So when we're building, we're going to need more higher skilled labor. Yeah, we're going to need fewer bricklayers, right? We won't need any. But those bricklayers can use this machine instead. What we're going to need are more tradies in other departments. We're going to need more carpenters. We're going to need more electricians. We're going to need more plumbers.
Yes.
So in terms of net benefit, the net benefit unemployment will be huge.
So, you have been on multiple podcasts, as in research circles, talking about salutogenic design, mental health, and evidence based architecture. What's been the hardest part of bringing that research into everyday practice, into real projects and real constraints?
There's been a few challenges in that one. The biggest is always money. People imagine that salutogenic architecture is going to make things more expensive, whereas it actually doesn't. It makes things cheaper, but people's imagination counts for a lot. I have to backtrack here and explain some of these terms that you mentioned. So salutogenics, which is one of the most important models which I use for understanding the impact of the built environment on our mental health and physical health, runs on a fairly simple model. And the idea is that as we live our lives, we are constantly being bombarded with adversity of one kind or another. And it might be physical adversity. It might be literally physically the difficulty of getting out of bed. Or it might be a biological one, such as germs or other things. We've got lots of adversity. And what helps us cope with that adversity are three things. Manageability. That means the ability to just get on with the things that we have to do. Comprehensibility. That is the ability to understand the world that we're in and understand the bigger picture of what we have to do in order to do the thing that we must. And then, most importantly, meaningfulness. If we can find meaningfulness, we can survive any lack of manageability, it seems. The most incredible studies of this were done by Viktor Frankl in the concentration camps of Europe during the Second World War, where he discovered that people who had a developed sense of inner meaning, they were able to even thrive under the most adverse circumstances. So that we can use our design principles to embed these three qualities, if you like. All architects will try to some extent to make a place that they build manageable. Maybe not all architects, but a lot of architects will. And that means, things like having a room that cuts out noise, for example. It's a really basic thing. Comprehensibility is about wayfinding. It's about showing your status and so forth to the outside world. Some architects are better than that, are better than others at that. But meaningfulness is usually something that architects avoid. They think that they can't do it, but they can. We can create meaningfulness in all sorts of ways. And one of those ways may well be to build with Earthbuilt. Because by building with Earthbuilt and other materials that avoid the ultra-processing of construction materials, we can really demonstrate to ourselves and to the outside world that we're doing good. And we can look back on our acts and go, we didn't do so bad after all. We're not contributing to the problem. And knowing that you're not contributing to the problem is definitely part of the solution.
So, if we fast forward 10 to 20 years and things go the way you hope, what does the built environment look and feel like on Earth and perhaps in the first off-world settlements?
I do have a vision. I fully anticipate that there will be no homelessness for a start.
Yeah.
So people in San Francisco, take note. We can solve that problem. There'll be no homelessness. There'll be a lot of multiple residential dwellings that knit around each other to make very environmental, social environments that work in a coherent way with each other, giving people the affordance to meet and enjoy spaces together. There are some fantastic models for that, which I've been observing all over the world. And I think that we're going to see a lot more high quality development and less low quality development. Low quality development meaning house with nothing in it, followed by house with nothing in it, followed by house with nothing in it, and no general affordance, no general opportunities for the whole suburbs. That model can go because there'll be enough money saved.
Yeah.
That we can have good community centres, not just community centres as in buildings where nothing happens, but community centres where things can happen. We can develop our love of theatre and religions and arts, and we can have social spaces where we can go swimming and play our sports and enjoy nature, because there'll be much more opportunity to do so, and our environment won't be quite so badly degraded.
I really love that vision, especially the idea that smarter, more automated construction could actually give us more human spaces, not less.
Absolutely. So one thing that is really worth noting is that, I don't know the figures for everywhere in the world, but in Australia, 45.5% of all of our terrestrial waste, that means our landfills,
Yeah.
is construction waste.
Yeah.
Imagine if that space wasn't there, if we could halve the amount of construction, the amount of terrestrial waste that we were producing. That land can then be given back to the nature that was always there. That can be for koalas. That can be for kangaroos. It can be for fields. Whatever it is, we shouldn't be consuming so much of the world's resources just to process our waste.
So we now discussed on Earthbuilt and the technology behind the construction. I would really love to talk about your journey.
Yes, of course.
Yeah. So your background spans fine arts, architecture, and ultimately a PhD in architecture with a deep focus on how environments affect our minds. Can you walk us through your journey into design psychology?
Wow, now that's a step around. Okay. I became interested in design psychology when I was working for a small medical-oriented design firm, and I had to work on designing a mental health facility. And I won't name her, but I was speaking to my boss and saying, well, where's the research? Well, how do we design an environment that's actually good for people in terms of design psychology? And I was told, oh, no, we don't do that. We just follow the rules. And then it turns out that our firm was writing the rules as well, not just for our firm, but for everyone. And I ended up working for the firm that was putting together all these rules, and I realized that the rules were just coming out of nowhere. They weren't substantiated. They had no basis. It was all just rubbish. It was all just policy and rubbish and nonsense and vacuous. And it was expensive as anything.
Yeah.
And so I started looking at it, what we could do, and tapping around the edges. I think I did quite a good design for that mental health facility, but I did go back to university and I did do a master's degree focusing on the subject, which was essentially finding out what the problem was. And then I went on to do a PhD. And I was very lucky when I was doing my PhD to have a visiting fellow at our faculty at Sydney University at the time who was a neuroscientist. And he said to me, look, you seem to be pretty good at the architecture thing. Why don't you just let go of it for a while and focus on what you're actually trying to do, which is design psychology? Let's look at the psychology bit. Let's look at the neuroscience. What is it that you're trying to do? And whilst doing that work with him, I started discovering stuff that other scientists have previously discovered, but they didn't know what they had discovered. I was looking through their data and going, hang on a second, this genuinely applies to architecture, genuinely applies to built form, your discoveries. And yet you're scientists sitting in an office and you don't even realize this. You think it's all about mental illness. And so a lot of the more severe mental illness is deeply connected with bad relationships with the physical environment.
Yeah, I have this habit of reading books written by Dr. Joey Dispenza.
Oh, Joe Dispenza.
Yeah.
Okay.
So I keep a lot of reading a lot on his experiments, results. I'm like, oh, that's really interesting.
Yes, it is interesting. But I am in the process of writing a book about how the environment affects us and why. And I've got an agent in London who's busy selling that book, and it's going to be a fabulous book. It's about 70,000 words in. It needs to get to about 100,000 before it will be published.
I'll be waiting for that.
Yeah, thank you. I think Joe Dispenza might be as well.
Yeah. So for all our listeners who might or might not know the term what is architectural design psychology or environmental psychology in practical terms, how does it change the way you design a building or a city street?
So environmental psychology is really about understanding what our design actions do for people.
Yeah.
So a lot of design actions either ignore the people or they quite deliberately manipulate the people for a particular purpose. Most design psychology we see is about retail psychology. So we go into an H&M, great example of a store that's very successful. You'll notice if you go into an H&M that when you're browsing, there's softer light and a nicer environment. But then when you get into the queue to pay, you're put under this savage light. Why is that? The reason is, and I don't know if they know it or not, but they've certainly found it in their checkout results. The reason is that they want to get people, once they've made their choices and they have their basket full, they haven't added it up properly, they want to get people out of the shop as quickly as possible before they reconsider their purchases. And so their trick is that they make an environment which is local to the checkouts, where people do feel uncomfortable, where people don't want to hang around because they're in the queue at that point with a basket of goods. And if they're given time, they might go, hang on a second, did I want this? Did I want this? And they'll be reducing their baskets.
Yeah.
So they want to get people through as quickly as possible and in an uncomfortable situation so that people don't feel to stay at that point. So it's one example of design psychology. There are plenty. I've written a lot about IKEA, for example, hoping that Disney will give me a residency next year to go and spend some time in the happiest place on earth so that I can learn more about what they're doing and so they can learn more about what I'm doing. And all of these big firms use design psychology and usually very effectively. There are very few people that use it for health, but there are a few. A real shout out to John Zeisel, for example, who's been using design psychology for a very long time to manage dementia, for example. He's a very close friend of mine, and we work together well. And it can be used for that too. We can use design methods to compensate for mental loss.
Yeah. So you led psychological design, which is described as architects with a difference, deeply immersed in environmental psychology and evidence-based design. What kinds of projects you actually work on and what makes your approach different from a typical architectural firm?
Look, most of my career has been on health work, and nowadays a lot of it is on dementia care and aged care work. If I'm working on it at all, to be really honest, most of my work right now is on Earthbuilt. There's only one of me currently. I'll see if I can deal with that. But one of the things that I will do with a health campus, particularly a dementia campus, is I will turn it in on itself, very much like I will when I'm building on the moon, because we have to create environments that are secure, but have no walls. I mean, they have walls, but they don't have fences. We don't want people to come across a fence because a fence says you can't go past here. You can see past, but you can't go past. There's a fantastic example of a aged care home in Auburn in New South Wales called Gallipoli Home. They consulted or had me consult them for a while, and they had some jokers build this place, and it's kind of pretty, it's beautiful, but they just didn't think things through. And whenever you're in this space, you're facing these walls, these fences, and beyond the fences, there's all this interesting stuff. The home is mostly for Muslims, and there's a mosque across the road just outside the fence. But you can't get there. And that's torture. So the first thing we have to do is turn buildings inside so that people aren't looking to what they can't have, they're looking to what they can have. And then you have to make it rich, an environment with lots going on, so there's plenty to do on the inside. Makes it much safer as well.
Yeah, it does. So most of your work is on the concept on salutogenic design. So design that actively supports health and flourishing rather than just avoiding harm. How does salutogenic thinking show up in your projects, say in healthcare, aged care, or mental health facilities?
So the turning of the building inside out, so it looks inwards, is obviously a measure to create manageability. It means that people find it easier to manage because they're not creating desires for themselves which require them to go beyond the environment where they're allowed to be. This is particularly so obviously for dementia people. People who don't have dementia, they can leave. They can leave easily. They know how to do it. But if you do have it, it doesn't foster those desires to be elsewhere, making life far more manageable. It makes it more comprehensible too, because it makes their world smaller.
Yeah.
More easier to cope with. It's not the huge environment that they find themselves in. There's no wandering, getting lost and wandering around a car park. There's no getting lost and wandering out into the city if you're in an internally faced environment. And by the way, the internal facing of the environment is just one of many methods that I use. But we also create meaningfulness by creating lots of things to do. And those things have to be defined by the quality of the things that are on offer. We have to not just offer things to do, but they have to be things that are conspicuously good to do. So an example I like to use is a mental health facility that I designed with some colleagues in the Middle East. And it was a mental health facility, and the entry procedure was very much like any other entry procedure of mental health facility anywhere in the world, in that the police come and they just want a gate that they can back up against, that people can't back through the gate. It's called a sally port. We designed the sally port in such a way that it opens not into what's standard processing room and then a room where people are put into isolation essentially, because usually people are dumped, they're processed, they're injected with chemicals to calm them down because they're usually angry by this stage, and then they're put into a room just to sort of fall asleep for a while, which is an isolation room. This is not a good way to arrive at an environment. And anyone with severe mental health who have been through this process can vouch for this. It's common and it's everywhere. It's not just in Australia. In fact, Australia is better than many places. So we designed this environment. The Sally Port exit isn't a processing room. It's a really nice living room. And it's got things to do in it. And one wall is open to a big garden. And that garden, in terms of visuals, is open. There's no fences. You can just leave. Or so it appears. Actually, you can't. But you can't see that immediately. There's nice furniture. There's things to do. There's a juicing machine. You can go and make yourself juice. What we're trying to tell people is that this environment is a place where health is respected first. You're coming here because it's a great place to take respite and recovery. And so we're speaking a different language. And they're the kinds of techniques that we use.
Mm-hmm. So you often describe the environment as an extension of our brains, that it shapes our behavior, emotions, and even health outcomes. Could you share a concrete example where changing the environment led to measurable changes in behavior or well-being?
Well, everyone knows this. You go into a bathroom and you see how people behave in a bathroom as opposed to maybe a church.
Yeah.
Right? People behave differently. That's a concrete and noticeable change. And people go, yeah, of course, that's because I'm in a bathroom and that's because I'm in a church. These are physical environments. Half the processing of an environment takes place in the brain, in what you know, in your culture, in your beliefs, in your experience, and the other half is structured into the environment. And the interactions between the two is where we get perception.
Yeah. So, and also you have applied these ideas in some of very sensitive settings, aged care, dementia, mental health, and even secure environments, as we discussed before. So what have those contexts taught you about the power of design for better or worse?
Yes, most of my work has been in those very sensitive environments. And that's because it's those very sensitive environments where most architects founder, they don't know what to do. They don't know how to deal with it. And it's where those sorts of choices make the biggest difference.
It's really powerful to hear design talked about not just as how things look, but as something that changes behavior, health, and even dignity.
Absolutely. And look, for people, if they want to understand it, think about clothing.
Yeah.
You know, design, architectural design is like the clothing for society. It's like a level of design that we inhabit, just like clothing. When we dress in different ways, we behave differently.
Yes.
You know, if you're dressing for a ball, you know, in your ball gown, you definitely behave differently than if you're dressing for tennis.
Yeah.
You know, and I don't know if other people are the same, but if I go and try and train, like do my gym thing, and I'm not wearing gym shoes and I'm not wearing gym clothes, I can do it. But I find it's a struggle. I genuinely notice that I'm struggling, and it shouldn't be so. Like, okay, I've got the wrong shoes on. They're a bit heavy. So what? You know, today I'm lifting weights with my arms anyway. It's harder. I promise it's harder. If we dress appropriately for the things that we're doing, it's easier. And it's very much the same with our built environment.
I'm just trying to connect how we are trying to apply your experience, the concept into Earthbuilt.
Well, Earthbuilt, as I say, you know, it's really hard to thread that needle.
Yeah,
you know, the story behind Earthbuilt Yeah, there are several stories behind Earthbuilt, to be really honest. But I was designing using typical established earth building techniques, and then I realized that they didn't match the modern methods of construction. They didn't match how our builders structure their businesses. And so I couldn't actually get people to build these things that I was designing.
Yeah.
I had a problem. I had to change the way I was designing or develop a technique that would suit a modern construction methodology. And I did the latter. And so I got caught up in it, and I realized how important it was for the environment. And yeah, there are psychological aspects, but there's psychological aspects to all design.
Yeah. So
People will even design badly with Earthbuilt, is what I'm saying. Bad designers will design badly regardless.
yeah. So it was really amazing conversation with you. To end on a lighter note, if you could leave listeners with one key insight about how our environments shape us, our minds, our behavior, our health, what would it be?
The environment that we build around ourselves contains stories. It contains stories from our culture, from our experience, from our own ideas, and each one of those stories has a motivational factor.
Yeah.
There's no such thing as neutral in design. Design is either good and will be perceived as such, or it is bad and will be perceived as such. And anything neutral in the middle will either flick to good or bad depending on how you feel about the environment which you're in. An environment which suits the purposes that you're in is a good environment.
Yeah, it is. So we have a lot of students and early career professionals listening in architecture, engineering, space, and robotics. What advice would you give someone who wants to work at the intersection of design, psychology, and technology?
The people who want to work in design psychology, the most important thing is that they care about the human experience. And for people who are looking at design in general, the most important thing is that they care about the environment that we live in. And so if you want to distill it to one thing, it's just care. You must care. And that means care about everything else. Put yourself last.
Yeah, I loved it. So for anyone who wants to dive deeper into your work, psychological design, Earthbuilt, your talks and research, what's the best place to find you online?
I'd say Google. I've got a lot of stuff online. Google, if you want to find about my life, you might want to read my memoir. It's called Magic. That's a great book, and there's a lot about that on the internet too. I've had a few lives. I've had a very big story myself. I've done a lot. I guess I'm an interesting person.
So, Dr. Jan, thank you so much for joining me on Spacefront Conversation. From psychologically informed hospitals and dementia care facilities to robots that can build sustainable homes in a day and maybe one day lunar bases. Your work is such a powerful reminder that designs is never just about objects. It's about people, health, and possibility. To everyone listening, stay curious, stay inspired. If you enjoyed this episode, please follow Spacefront Conversation and also Earthbuilt. Share it with a friend or a colleague and let us know what you would like us to explore next at the intersection of space, technology, and human experience. Until next time, this is Divya signing off.
Thank you, Divya.